welcome back, everybody. It's the RT Machine Podcast. Our normal host, Eric, is not here today, so I'm filling in. This is Ron, and there's just three of us in today. We got Dean here running the board.
Yep, Dean's here.
And we got our special guest in the studio today, Bryson from Ultimizers. Introduce yourself and tell us a little bit about your background there, Bryson.
Well, yeah, my name's Bryson. I started at Ultimizers in 1989. I was a welder within the company. I basically held every job in the company on my way up. Service, ran the shop, still running engineering, sales manager, and for a short stint was general manager.
Wow. And before that, did you have other jobs?
I was in the military.
Oh, okay.
Came right from the military to Ultimizers.
Yeah. What did you do in the military?
I was a steel worker is the trade name, but it was welder fabrication.
So that's how you had the welding background?
Yep.
Okay.
Yeah.
So Ultimizers started out, as I remember way back, they were selling upcut saws.
So when I started there in 89, the primary business was manual upcut saws. And the secondary business, which was fairly new at the time, was automated chop saws.
Oh, okay.
And material handling. So there were basically one big building, but with two companies running independent within it.
Oh.
It slowly merged together over time. And eventually the manual chop saw side went away. Mm-hmm. And all we have now is the automated side.
Right. Yeah. So tell everybody, when you talk about an automated chop saw, you're talking, we call them optimizing saws, automated chop saws. They work off of crayon marks in the beginning, what you sold.
Yeah. In the early days, it was all crayon marks, even to the point, not just crayon marks, but they also had what they called laser markers. Mm. And so as there would be a laser on the board, and as the board would go by an operator, he would hit an A, B, or C grade button or waste. And that system would then know the laser was just there for him to see it. Mm-hmm. But when he'd hit the button, that would identify at which location things were at.
Oh, yeah. Never saw one of those.
Yeah. And then it went into hash marking, like most arts still today. We developed one of the very first, what they called character recognition marking, where you could literally write the letter A on a board or B on the board or whichever grade you were cutting. And so you would put hash marks and then say a letter C in between the hash marks, and it would know that would be third grade, for instance. Then from there, it eventually led on to scanning.
Yeah, where you do no marking, no operators. It just goes through cameras and scans and chops.
Right. We were the first company to ever bring a scanner into the United States. It was the early days of Wood-Eye at the time.
Okay.
We went searching for something to get rid of markers and found Wood-Eye. They were brand new at the time. And we basically became a dealer for them in the United States and sold their scanners for along with our systems for probably maybe 4 or 5 years. Mm-hmm. Then decided that it was probably not a good fit for us, and we started developing our own.
So that had to be quite an undertaking to hire software engineers and programmers to build your own.
Yeah, at the time, one of the companies that were really putting the most amount of money into scanning at the time was a company called USNR, which is a big primary manufacturing sawmill type company.
Oh, okay.
And they still are to this day, of course. And they still are one of the, probably putting the most money still into scanning, I would say.
Really?
Yep. They had produced a product that it was a scan head, and we were purchasing that product from them and working with their software people to make it work. And after a few years, they decided to shelve that product, and it kind of left us out in the cold. So we had developed a really good relationship with their software people, and they came to work directly for us, and we started developing our own scanner with software guys from USNR, and then that's kind of how we got started, and then they're still with us today.
Yeah, and a lot of that was softwood stuff that you were doing out your way, scanning and chop saws, right? In the beginning.
100%. Yeah.
100%,
Yeah.
yeah. And now, of course, moved further to the east, working with us, and we're talking more hardwoods, which are more difficult to scan.
Some, certainly things like black walnut, mahoganies, those kind of things are really tough to scan because most all scanners now are developed based on a laser technology, and some woods will absorb laser, and it's hard to get the data you need from it, and so there are some woods that are really hard to scan. But for the poplars and maples and ash, some of those species are easier than pine to scan.
Oh, really?
The big difference is the softwood industries have a lot more grades than the hardwood industry does. So it's not uncommon at all for there to be 15 or 16, even 20 grades in softwood rules.
Oh, yeah?
Yeah, and most hardwood guys have about 4.
That makes it easier.
Yeah, it makes it quite a bit easier.
So explain a little bit. We always hear the scatter laser, dot laser. I'm sure some people listening will have no idea what we're talking about, but can you explain that a little bit, what those are and how that all works?
Yeah, it's an easier thing to draw than it is to explain.
I'll bet.
But basically the idea of a scatter is wood cells basically look like empty straws. They're very similar to fiber optics. So when you shine a light down on top of the wood enters that straw, and instead of continuing through the straw directly,
The laser.
Yeah. So when you shine the laser down on these straws, the light will glow down like through fiber optics sideways, and the longer that light glows, the clearer the wood is. So it's kind of a misconception, but we're not really looking for defects. We're looking for clear wood, and with the lasers.
Yeah.
Anything that isn't clear wood will absorb a lot of the light. It won't transfer down through the fiber optics of the cells, and instead it'll try to enter into the wood directly. And so we won't see that glowing or the scattering effect of the light. And so we know that there's something else there.
Yeah. And then you confirm, you recheck that with the camera, and then.
So then it takes a lot of technologies, because that's an easy one to trick with, say, a footprint or grease. So we'll use a second technology, which is called dot lasers. And a dot laser is the exact same thing, but instead of being a solid line across the board, we just shine a dot at the board in different locations. And that light will still travel through that cell, but if the cell is angled, then we can actually see the light turning as the cell wraps around, say, the side of a knot. Because the knot is circular, the cells will turn, and the dot will follow that turn through fiber optics. And so we can see the angle changing before and after a knot. So if we see a footprint, let's say the line scan laser sees something blocking the wood, and let's say it's a footprint, the dot laser won't necessarily ever turn. So it's almost like a predictor. The dot's turning, and so we say, oh, something's coming. Oh, now the line laser disappeared, so that may be a knot. And now we see the dot turning the other way again, so that's the backside of the knot. So it all makes sense, right?
Right.
And then on top of that, we use color. And then color cameras, we can say that, we know that knots may have a red hue, whereas a chain mark has a black hue. So we can ignore the black in that same situation where the curve is going around in the lasers.
Right.
But then we know there's a red hue which matches a knot, and so we can identify it as a knot.
Yeah.
And then there's other things like profile. So a lot of knots will have a split in it, And the profile laser will literally fall down inside the split, and we can see that there's missing wood there. And if that's right in the center of where we think a knot is, then we know that's, say, a loose knot or a star knot.
Right.
We call them.
Just confirms everything.
Yeah, and so there's check and balances constantly on everything we do. And there's a lot of signals that we have to look at different thresholds for.
Yeah, and I remember one of our projects together, you measure the board constantly, like, was it every fraction of an inch, right? What was the number?
Well, it's 1,500 frames per second. That's how many, we're taking 1,500 pictures a second. And so you divide that into the length of the board.
Yeah.
And that's how many, which ends up being about, at full speed, about a scan every 50 thousandths of an inch.
That's a lot.
It's a lot.
It's a lot of data.
Yeah, a board file is not uncommon to be 10 or 12 megabytes
Wow.
per board.
And you've seen them getting faster and faster as computer technology's gotten faster and faster. I know you've told me about that.
Yeah.
So things have been easier to get more information into it.
Right.
And I think some people probably don't understand that the human marking the board was only going to get so close to the knot, and you can get closer to that defect with your technology, as well as maybe leaving a little bit of edge defect that's going to be taken out on a molder or a rip saw. You can save that board, and so the scanner is going to get a lot better yield than what even a marker can do with a saw.
Yeah, markers are famous for crooked lines, and so depending on where the line goes across the board at the same place that the sensor looks for the camera line across the board, you can be easily half an inch off just in that, and that's common.
Right.
As they're going so fast, they're trying to mark fast.
Right.
And then markers tend to mark differently when they're being watched too. So if you're standing there watching a marker, they tend to mark real well. But as soon as you go away, they tend to mark farther away from defects.
Yeah.
And they're always trying to be safe, right? They don't want to have the parts kick back on them.
Yeah.
They don't want to be in trouble
Right.
by somebody downstream.
Yeah.
So they tend to mark farther away. But the biggest thing about a marker is, in my opinion, that we've seen, at least as far as data goes, a marker doesn't understand all the part lengths that are needed,
Mm-hmm.
and how many are needed and how much they're worth. So there are times when the scanner, we can identify a knot as close, very, very closely. That doesn't mean we're going to cut near the knot. The software is smart enough to know that if it cuts too close to a knot, there may be a chance of edge grain or something like that. So if the solution allows it, it pushes away.
Right.
With the cram marking system, you don't know that.
Mm-hmm.
You just simply cut near the marks.
Right.
And so that can cost you parts sometimes, and it can cost you grades other times in dollar value.
Mm-hmm.
The other thing is markers they're okay with marking knots and some items, but it's when you can save a part. Like for instance with Wayne, if you have a molding and you're going to mark, or you're going to mold out, so let's say 3/8 of an inch off the edge of a board, well then 1/4 inch of Wayne is fine.
Right.
A marker or a human can't just easily look at Wayne and determine how much is there.
Difference between 3/8 and letting 1/4. Yeah. Right.
Yeah, and so as the Wayne, and especially as the Wayne gets bigger, so if you have a molding that can allow a lot of Wayne, well, a guy has a real hard time telling between 1 inch and say 1.5 inches
Right.
even. At high speed, he's trying to mark, and the Wayne's changing all the way up and down the board. He's not going to be as good as a scanner.
Right.
So he also isn't going to be able to determine width as well. These scanners now, I think our scanner, we're probably scanning width to within 0.010 of an inch. Well, a guy probably can't look at a 6-inch board and tell within 1/4 inch
Exactly.
what the width really is.
Right.
So a lot of that kind of stuff, it's not that markers aren't great at marking things they see, and they may see more than a scanner. in some cases, but it's all the other cases that the scanners win.
Right. Yeah, I remember that when we don't do a lot of softwood stuff, but we did that one project for finger joint, and how critical it was to measure the width, because once it got to the finger jointer, if it was too narrow, you just messed up that whole strip that they finger jointed back together.
Oh, well, the big one is edge glue panels, you know. If a board comes through with a narrow spot and you think it's good for a random width edge glue panel, you glue it up and all of a sudden there's a 1/16 of an inch opening through there.
Right.
The whole panel's bad and you put a lot of labor into
Yeah,
it.
exactly. Yeah.
So, yeah, so a marker just isn't as good as a scanner.
Yeah, just can't keep up.
Just
with it.
can't do it. Yeah.
Yeah. So you do a lot of you do the engineering, you do a lot of material handling, a lot of custom projects, which we have one going right now that you just completed or what's ready to go for testing, right?
Yeah.
Runoff.
Really almost every job is custom for our company.
Yeah. And you do all those drawings and design work and stuff for that.
That's my favorite part of the job.
Yeah, I knew you said that. Sometimes you like to to draw stuff.
Yeah.
So then how did you learn that coming from a welder? Did you take classes or go to school for?
No, just through the company. Like I said, I was a welder, and so I understood fabrication and machinery. I got into the service side of things and was fixing machinery all the time, so I was having to read prints a lot.
Mm-hmm.
As I got into I was running the shop for a long time, so purchasing and all that, and so drawings became more and more something I was just dealing with. And I don't remember exactly the storyline, but at one point the owner said, "Well, why don't you just learn this stuff?" And he sent me to AutoCAD had a class, introductory class, and I went to it. It was half a day, twice a week for 4 weeks or something like that. And I went to the class and I started learning it, and it just took. I've never learned to program that fast, and I just loved it. Started drawing my own machinery and at home messing around. It was so exciting. And then before long, I'm drawing real machinery for the company.
Did they have somebody else doing it before that, or?
They always did.
Oh, okay.
It got to the point which is where we're at now. I don't do any true shop engineering, shop drawings. I do all the, what do I want to call it? Design work. So I determine a design or something that we want to work on. I'll prove it out in AutoCAD, or I use actually 3D modeling now to do that.
Oh, yeah.
I'll get it to the point where I know that the design works, fits. You can get it into a location. You can get to the bolts to tighten them, things like that. And then I turn it over to our drafting team, and they then turn it all into AutoCAD now and into shop drawings, and then it goes out on the floor and we build it.
Start to build it.
Yeah.
How many employees do you have out there?
We range between 10 and 15. We're probably in the 10 range now.
Just can't get people.
That's part of it. The other part is that we used to run bigger crews, 30-man crews, but the business model has changed so much. We're doing a lot more technology now, so we don't need as many people in the shop to do the same amount of dollar volume per order.
Okay.
Also, like our customers have to do, we are automating more and more. And so in the old days, you'd take a piece of channel iron, you'd have a torch and a welder and cutting, the hacksaws, and they would cut out everything you needed. Today, everything is laser burnt. We call it all in, so we don't need 12 fabricators anymore to build a machine. We have 2 guys, and they're almost assemblers now that can weld versus true fabricators. So we're producing really, I think, a better machine with less people, and it's quite a bit more accurate than we've ever had.
Yeah. Your saws are very heavy built. We went right to scanners, but your saws are some of the heaviest ones that I've seen in the industry. Heavy tubing, heavy steel. The arbors are much heavier than everybody else's, and you don't hold back if it's a purchase part. You let people buy it. You don't really try to make them buy stuff from you.
Yeah. So the company, going back to the start, we were on the West Coast, manual chop saws. We were producing 18 to 20 chop saws a month when I first started with the company.
Mm-hmm.
And they were all going to the really big, high-end pine producers on the West Coast. And they're very hard on equipment, and they're very hard on vendors. So, well, I shouldn't say hard, but demanding for sure. And so you had to build things like a sawmill would build it, not like a secondary manufacturing guy would build it.
Yep.
And so we started building everything to those kind of standards. The owner worked for a company for a long time that had a big service division, and he always thought the service division was a problem, that it was a money costing part of the program. He thought it was taking away from profit. So he wanted to design service out as much as he could by building everything heavy. Mm. And so that's all part of it. And we still stand to that today. Basically, you might be able to get away with the 3/8 bolts, so why not use a 1/2-inch bolt? Those kind of things are just standard. We just think that way.
Yeah.
But because of that, we've got machines out there running today that are still 35 years old. Mm-hmm. Some of the very first machines I built while I was with the company are still in service today, and the customer can't justify replacing them because they're still running them and they know how to run them.
Right.
The other part that goes along and hand in hand with what you were saying is that parts. Again, the owner working for another company in his younger years thought the parts business was hard to deal with. So he didn't want to be a bearing house. He didn't want to be, a supply house for photocells and those kind of things. So when we started producing our parts list, we would, of course, everything has to have an Ultimizer part number. Mm-hmm. But right alongside of it, we'd just say, well, it's an 1.5 VAK bearing. So you could go source that wherever you wanted to. You didn't come to us for that. And still to this day, people don't buy that stuff from us. Yeah. We really just sell the components that we make that you can't buy anywhere else in the world.
Yeah. Yeah, I saw that. I was at your plant and saw that. Jumping around a little bit here, but tell people the kind of speed, the kind of production that you run on say a marking saw and a scanner saw. I mean, they're so much faster than an upcut saw. You can replace multiple upcut saws with just even a marking machine.
When I first came to the company, the standard answer to that was four manual chop saws.
Oh yeah,
would be replaced by one optimizing saw. But saws have gotten so much faster, and I would say for the average guy, in the somebody producing 10,000 feet or more, let's say, per shift, one saw can produce as much as 4 to 6 or 6 to 8 upcut saws.
Mm. Wow.
Yeah. And it doesn't really matter. Production isn't held back by marking if the marking system's right. So really that's a saw function for speed. The not that cram markers can stay up with the saw, but if there's enough of them and enough material handling around it, then it can. So
yeah, we've seen saws having as many as 4 markers feeding a saw.
Yeah, that's common, especially on my side of the country, especially with pine, with all the grading involved.
Yeah,
it takes that many because they're, it's common to cut average cut length on our side of the country is 9 inches long.
Yeah, right.
So they're marking lots and lots of grades for finger joint.
Yeah, that's got to be a tough one.
Yeah,
and your scanner can then keep up with 2 saws if you wanted to.
Ours can. We can scan at basically 500 feet a minute is the number. Mm-hmm. And if everything's right, that's a great 2 saw line.
And that would produce how much lineal footage?
Excuse me, 120,000 a shift.
With 2 saws?
Yeah.
So each saw is going to be 60.
Yeah.
Markers.
Those are average.
And markers could do that too if you had enough markers. Is that fair?
It's fair, yeah. What's really hard about having that many markers is all the material handling to deal with it.
Right.
And the space that all takes up. And then, of course, if there's a glitch, you get hung up and you lose some time. So
that's right.
That's the hard part.
Yeah, and handling the material, the type of material we have can be finicky because boards are twisted. They're not all straight.
Yeah,
flat.
I wish we had the steel industry's problems.
Yeah. Yeah, that's some customers don't seem to understand that, even though they deal with that every day, right?
Spaghetti almost sometimes.
Yeah, it can get pretty nasty. Yeah, so I don't know any other projects that are interesting that you could talk about that you're working on. I know we're going to see one tomorrow, which is two saws we're quoting there. A wide one and a narrow one, rip first and a crosscut first. Because we didn't talk about that, but you can do wider for crosscut first.
Yeah, it's interesting. That's a whole storyline. When I first came into the industry, probably a good half of the people we talked to on the hardwood side of the world, East Coast, were chop first, rip second.
With straight lines, or
yeah, the old straight line.
Mm-hmm.
Yeah. But they had wide wood. And so it made more sense. And of course, the industry quickly changed over to rip first, crosscut second.
Right.
But as the lumber is getting narrower now, there's a lot of benefit to a lot of people to go back to chop first, rip second, because the boards are more bowed, they're narrower. And so in some cases, rip saw just can't get the yields out of it.
Right.
So it's funny to see us shift back, to many of the old things we did a long time ago. So we're building a lot more of the wide chop saws than we have in a long time.
And you go up to 16-inch?
We actually build a machine that goes to 36, believe it or not.
Oh, really? I never saw that one.
Yeah.
I guess I never had an application for that.
Yeah, and it was a furniture manufacturer that was doing really super high-end. They were bringing in mahoganies and stuff right out of South America.
Yeah.
So we built a saw to do that.
Probably haven't sold too many of those.
One ever, yeah.
Oh, just the one?
Yeah. But we do have designs for 24-inch and a 20-inch, 18-inch, and now a 14 is a standard, pretty common.
Right.
If the wood gets more than 14 inches wide, it makes sense to go, back to rip first again.
Right.
Yeah.
Yeah, it gets hard to handle.
Mm-hmm.
And that is some of the stuff we're talking about. This other location is some heavy, wide, thick material that they want to try to avoid handling, and that's why they called us in.
Yeah.
So, all right. Well, I think that's all I've got. Dean doesn't have any questions. He's been awful quiet over there.
I've just been soaking it all in.
It's not all that exciting stuff.
It's a lot of stuff that people don't think about, though. It's not an everyday woodworker's application, like a shaper or a molder. I mean, it's pretty high-tech stuff you get into.
Yeah, it's interesting. Just thinking about all the years and where we came from. Where I can remember when the computers that we were using have less power than what you have on your wrist.
Yeah, right.
And that's how we
right.
started. And now
we're
doing what we're doing. 30 something processors, and it's just insane.
Yeah, it's like when we talk about some of these projects, and you're like, well, I need a little bit of time for the computer to make a decision before I get to the saw.
Yeah.
You see it going so fast, you think it just always does that.
Half a second. Yeah.
It's crazy. All right. Well, I appreciate you getting on here and telling your story and telling a little bit about your company. And we'll move on to the next time, Dean. Thanks, everybody.
Thanks, guys.
Don't forget to support our buddies at Green Street Joinery by subscribing to the American Craftsman podcast and their new YouTube channel, Today's Craftsman. Both links in the description of today's podcast.